And we are back. All right, so what this lesson is going to do is really combine a handful of things that we've done this year. All right, so you're going to see table values, you're going to see graphing, you're going to see systems. All right, so you're going to see a lot of different pieces. All right, kind of all merging. All right, in this concept that I can write and solve systems of equations representing real world situations. All right, with information. All right, so once again, the good news is there's no real new skills to teach you. All right. But if you don't know a certain skill, please pay attention to that. Maybe highlight it. All right. Underline it, circle it so that you know you can go back and study it. All right. And become a little bit more, and to make that a strength versus a weakness. All right. Because you're going to see lots of different things kind of move in as we go through this lesson. All right. So we're going to actually do the opener in two parts, right? So there's two problems to the opener. So I want you to do problem one. All right. Pause the video, do problem one, and then let's discuss it. Then I want you to do problem two. All right, so let me read problem one here. A cell phone company offers two different plans for service. Plan A costs you an initial fee of $100 and then a monthly fee of $20 after that. Plan B has no initial fee, but costs $40 per month. When will the amount paid be the same for the two plans? And after 10 months, which plan should you choose? And what we're going to do is we're going to go back to table of values, right? And we're going to work on this, all right? So go ahead, all right, and pause the video, do that first problem, flip it back on, and let's see how you did. All right, so let me show you my work here. All right, so I went ahead and went right into the table, all right, and if we have an initial fee, that means that month 0 is $100, and then our monthly fee is $20, so you can see that's going up by 20 each month. With Plan B, there was no initial fee, so I didn't pay anything, but then I had $40 per month. And what you can see is that at month 5, all right, we'd pay the same amount, right? But by the time we get to month 10, if you extend the table here, Plan A, you've only paid $300, and Plan B, you paid $400, all right? So if we're going to go for 10 months, we'd want to choose Plan A because it's cheaper. Now, another way of doing this problem, and maybe some of you did this, is that you could have used some of that prior knowledge that we had in Unit 3 about writing equations, right? So you had a point and you had a rate of change. So you could have said, oh, Plan A, my starting point would have been 0, 100, okay? And then my slope was 20, all right, dollars. And so you wrote your equation that it was 20x plus 100. All right, maybe for Plan B, you said, oh, my starting point would have been 0, 0. My slope was 40, and maybe you wrote 40x. All right, then you could have generated, all right, some values from your equations. All right, so there you go. So you could have done table of values, all right, or you could have written an equation, plugged in some values until you found that they were equal. Either way is fine. It's also nice to have the equations to verify, right? So if I plug 5 in, right, I should get 200. If I plug 5 into this equation, I should get 200, right? So writing the equation can serve as a self-check as well. All right, so now, all right, let's jump down to problem 2. All right, and we're going to solve this one, all right, graphically. And so what you're going to do is combine two skills here, right? You're going to combine the skills, all right, of writing your equation from context, which we did in the last unit, with graphing your lines and finding that point of intersection, all right, to find your solution. So we have two different alligators here, all right? And we want to figure out, okay, so when will the alligators weigh the same and how much will they weigh when they do weigh the same? And we have Alfred here who has an initial weight of 4 pounds, all right, and his growth rate is 1.5 pounds per month. Then we have Annie whose initial weight is 6 pounds and her growth rate is 1 pound per month. So once again, I want you to pause the video. I want you to write the equation, all right, for Alfred and Annie. Then I want you to graph both equations and find that point of intersection. All right, and then we'll see how you interpret that point of intersection in regards to, all right, the solutions that we want as far as how many months and then how much will they weigh. So go ahead and do that. All right, so here is my work. All right, so once again, my initial weight, that's my starting point, and that would have been 0, 4, all right, and then there's my equation, 1.5x plus 4. For Annie, my starting point would have been 0, 6. My growth rate is 1, so 1x plus 6. And then if we go to the graph, right, I start at 4, that's my y-intercept, and I go up 1.5 pounds per month, up 1.5 pounds per month. And I get to that. With Annie, it's a little easier, right, because it's 1. So I start at 6, up 1 to the right one, up 1 to the right one, up 1 to the right one. And what you see is they intersect at the point 4, 10. And so we have to think about, what do my variables mean, right? So notice this is 1.5 pounds per month. So what this is telling me is that X is representing the number of months. All right, and then what does that mean? That means Y is representing, all right, the total weight. So when I look at my point of intersection, I have to know, what do the variables represent? So since X represents month, that means that they're equal at 4 months. And then since Y is weight, that means at 4 months, they both weigh 10 pounds. All right, so that is how we're going to connect writing equations with systems and what a solution of a system would represent in context. All right, now to practice this, we're going to work on writing these equations and identifying our variables. All right, so let's look at the next page here. And so all we're going to do, all right, for this part is that we're only going to identify our variables and then write our equations, because that's really the toughest part. Because once we get those equations written, we hopefully feel pretty good about graphing them. All right, so if we look at problem 3 here, Daryl and Arjun are selling cookie dough for a school fundraising. Customers can buy packages of sugar cookie dough and packages of oatmeal cookie dough. Daryl sold 7 packages of sugar cookie dough and 14 packages of oatmeal cookie dough for a total of $189. Arjun, all right, so 3 packages of sugar cookie dough and 7 packages of oatmeal cookie dough for a total of $90. Find the cost of 1 package of sugar cookie dough and 1 package of oatmeal cookie dough. All right, and that last sentence is really the key. All right, so notice what it says: find the cost of 1 package of sugar cookie dough and 1 package of oatmeal cookie dough. So this sentence right here is really big, because that's going to identify our variables, right? We need 1 variable to represent the cost of the sugar cookie dough and 1 variable to represent the cost of the oatmeal cookie dough. And it doesn't matter which one, all right? But I'm just going to go in order here. Since sugar cookie dough came first, I'm going to let X be, all right, the cost, all right, of 1 package of sugar cookie dough, all right? And then I'm going to let Y be the cost of 1 package of oatmeal cookie dough, all right? So that is what we're looking for. And so we know when we get our solution, when we find our point of intersection, the X value is going to represent the cost, all right, of the sugar cookie dough, and the Y would represent the cost of the oatmeal cookie dough. So now what we have to do is look at other pieces of information here. I'm going to grab one more highlighter, all right, for us. Okay, so now I'm going to go back to what it tells us about Daryl. All right, so if we look at this sentence right here, Daryl sold 7 packages of sugar cookie dough and 14 packages of oatmeal cookie dough for a total of $189. So here's how we should think about this. 7 times the cost plus 14 times the cost of the oatmeal cookie dough would be 189. So that is my equation. So 7x plus 14y equals $189. All right, and notice this gives me an equation in standard form. All right, and the key to knowing standard form is typically you will not see a rate of change in the problem. All right, so notice when we're in slope-intercept form, point-slope form, we have a rate of change, something per day, per hour, per month. All right, if I do not have a rate of change, typically most of the time it's going to be in standard form. So 7 times the cost of the sugar cookie doughs plus 14 times the cost of the oatmeal cookie dough would be $189. Now, if we look at the next sentence, let me see if I can get that out. The next sentence for Arjun, all right, Arjun sold 3 packages of sugar cookie dough and 7 packages of oatmeal cookie dough for a total of $90. And so all of that information is our next equation. So 3 packages of sugar cookie dough plus 7 packages of oatmeal cookie dough equals, right, $90. And there are equations. Now, how would I solve this, right? I would find my x and y intercepts, graph that line. I'd find my x and y intercepts for this line, graph it, and then where they intersect would be the solution. And that's what we're going to get to in the next part of our lesson today. But right now, it's just focusing on identifying my variables, writing my equations. All right, let's move down to number 4. Okay, very similar type of problem here. Julio and Kaylee are selling wrapping paper for a school fundraiser. Customers can buy rolls of plain wrapping paper and rolls of holiday wrapping paper. Julio sewed 4 rows of wrapping paper, or excuse me, 4 rows of plain wrapping paper and 5 rows of holiday wrapping paper for a total of $111. Kaylee sewed 2 rows of plain wrapping paper and 3 rows of holiday wrapping paper for a total of $63. What is the cost of 1 roll of plain wrapping paper? What is the cost of 1 roll of holiday wrapping paper? So once again, these last 2 sentences here, or questions here, right, is helping us, right? These guys right here help us identify our variables. What do we want to know, right? We want to know the cost of 1 roll of plain wrapping paper. Well, that should be a variable, all right? So let's let X be the cost of 1 roll of plain wrapping paper, all right? And then now let's let Y be, all right, the cost, all right, of 1 row of holiday wrapping paper, all right? And so now we can go back, and in the same way we did the last problem, we can look for, okay, who bought what or sold what and how much did it cost, right? So if we go back to what Julio did, all right, right here, yeah, right, this tells us everything Julio did. So 4 rows of plain wrapping paper plus 5 rows of holiday wrapping paper equals $111. There's our equation, all right? Now let's look at what Kaylee did. All right, so Kaylee is all of this information. So Kaylee sewed two rows of plain wrapping paper and 3 rows of holiday wrapping paper for a total of $63. All right, and so there's that, right? All right, so we can see that those generate our equations. All right, now let's look at, all right, let's jump down to number 6 here. We'll say 5 for in class next time, but let's look at 6 here and talk about the differences between what we saw in 3 and 4 and what we're going to see in 6 now. So you're trying to decide on which online gaming plan to buy. Night Vision Gaming requires a $57 registration fee and then a $13 monthly fee. All right. 3 Thumbs Gamers requires a $40 registration fee and then a $16 monthly fee. When will the 2 plans be equal, and which plan would be better if you wanted a 1-year subscription? All right, so notice an immediate difference here. All right, so we start seeing that we have these fees and monthly fees, right? So we have a rate of change. So if we have a rate of change, we typically want to write our equations either in point slope form or slope intercept form. All right, so when I look at, all right, Night Vision Gaming, right? I have $57 registration fee. That's an initial fee, all right? And so that means that the starting point for this would be $0.57. And it has a monthly fee of $13. So that's $13 per month. And typically what you see per month, per whatever, when you're dealing with time, that's typically going to be your X variable, all right? So notice that in this case, $13 per month, well, we need to know how many months, right, that we're going to pay. So X is going to represent the number of months. All right, then Y is going to represent the total cost, right? So after 1 month, how much did I pay? After 2 months, how much did I pay? After 3 months, how much did I pay? So Y represents the total cost. All right, so now let's jump in and write those equations. So let's look at Night Vision Gaming first, right? So if I look at Night Vision Gaming, I have my initial fee, registration fee of $0.57 and a monthly fee of $13. All right, so that's the big information for Night Vision Gaming right here. All right, so now, right, that is slope intercept form, right? I'm starting with my starting value of 57, and then I have a monthly fee. So this would be Y equals $13 per month plus that initial fee, that registration fee. So there's my equation for Night Vision Gaming. Now, if we go to 3 Thumbs Gamers, all right, and we look at what information there, or we have there, right? 3 Thumbs Gamers requires a $42 registration fee and then a $16 monthly fee. All right, so once again, right, monthly fee, that's going to be my rate of change, right? So Y equals $16 per month, right, plus that initial fee, that registration fee, which is $42. All right, so there's our equations. And notice I would graph these slightly differently than I would with my standard form, right? So I can start at 57, go up 13 to the right one, up 13 to the right one. I can start at 42, go up 16 to the right one, up 16 to the right one. All right, so that's your introduction to, all right, solving these kind of real world problems. So when we get back to class, we'll do some more of these together, and right then we'll put them all together. So write the equations and solve them through graphing. All right, so once again, anything that doesn't really click with you, make sure you're writing that down, highlighting, bring those questions with you to class. We'll get them answered. All right, and I will see you next time, my friend.